Hello, today we'll be learning about polar coordinates. First, let's talk about how to plot points. You can plot points in radians or degrees, depending on the problem that is given to you. For example, let's say they give us a point 3, 5 pi over 12. If you remember, the standard form for polar coordinates r comma theta, r being the measurement of the radius from the center or the origin to the actual point, and then theta is the angle created by the positive x-axis and the angle where the point is. So we want to plot the point 3, 5 pi over 12. First thing we're going to do is locate 5 pi over 12 in our unit circle, which is right here. Then we're going to go 3 units towards 5 pi over 12, starting at the origin because of r is 3. So 1, 2, and 3. So that's where our point is located. Let's look at another example. -2, pi over 6. So now we notice that r is negative, so we're going to go in the opposite direction of pi over 6. Pi over 6 is here. The one on the opposite side is 7 pi over 6. So go 2 units towards 7 pi over 6, which will be here. If we're working with degrees, it will work the same exact way, but the measurements will be given to you in degrees. So for example, 4, 45 degrees. Locate 45 degrees in your circle, and then go 4 units towards 45 degrees. 2, 3, 4, that's where your point is located. Now, let's look at 2, negative 15 degrees. So now we're going to go 15 degrees clockwise, meaning this angle right here is 15 degrees, and then go 2 units from the origin towards that point. So your point is actually located there. If you want to convert from polar to Cartesian coordinates, remember polar equations are in the form r comma theta. Cartesian are in the form x comma y. So there is a connection to vectors. So if you were to graph your polar coordinate, the head of the vector will be the same as your polar coordinate. So if you remember your component form, which is magnitude of u times the cosine of theta, magnitude of u sine of theta, it will be related to your new x equals r cosine theta, which are basically the same things, and then y equals r times sine theta. Let's look at a specific example like 2, 15 degrees. So this is your r and this is your theta. All you have to do is plug them into your equations. X equals 2 times the cosine of 15 degrees. Y equals 2 times the sine of 15 degrees. Get your calculator. Make sure your calculator is in degrees. And then 2 times the cosine of 15. So now we know that x is equal to 1.932. We will repeat the same thing for sine. 2 times the sine of 15. .518. And then all you have to do is put them together. Your x goes first, and then your y goes second. This will be your final answer. They can also give you the problem in radians, which you will have to work out the same way. All you have to do is be careful that your calculator is changed to radians. For example, 3, pi over 2. Again, x equals r cosine theta, y equals r sine plug them in. 3 times the cosine of pi over 2, y equals 3 times the sine of pi over 2. Go to your calculator. Again, make sure you're in degrees. Make sure you're in radians, you're in degrees right now. So change it to the radian. Now we're ready. 3 times the cosine of pi over 2. Enter. So now we know that x is equal to 0. Repeat for sine. 3 times the sine of pi over 2, which is 3. So now our answer will be 0, 3 in Cartesian or rectangular form. If you want to convert from Cartesian to polar, your questions are going to look a little bit differently. So now they will be in the form x comma y. And you want to go to r comma theta. So the first example, let's do -2, 3. You do have to remember Pythagorean theorem. And it's a modified version using the variables that we've been talking about. So r squared equals x squared plus y squared. We don't know what r is, that's what we're looking for, and we will use the x and the y provided to find it. So r squared is equal to -2 squared, make sure you put in parentheses, plus 3 squared. So -2 times -2 will be +4. 3 times 3 is 9, so that will be 13. This is r squared, we want r, so we have to take the square root on both sides. So r is equal to the square root of 13. We are going to leave it as square root of 13 because we want an exact answer. Now all we're missing is the theta. So if you remember from vectors, a equals magnitude of u cosine theta can be used to find the reference angle. We're going to do that same thing, but instead of magnitude of u, we will replace it with r. So in this example, a is -2, r is the square root of 13 times the cosine of theta. All we have to do is solve for theta to divide by the square root of 13 on both sides. Now we need to find the inverse cosine. We are going to do this in degrees, so I'm going to change my calculator mode to degree again. Now I'm ready to find inverse cosine of -2 over the square root of 13. So now we get that our angle is 123.69. And remember, it's negative and positive. So I'm going to go -2 units this way, +3 units this way. So I will be in quadrant 3. It does make sense for my angle to be 123.69 because it should be greater than 90 but less than 180. Remember, if you're in the bottom 2 quadrants, you have to subtract the data that the calculator gives you from 360. Okay, let's do another example. This one will do something in quadrant 4, 7, -5. Again, r squared equals x squared plus y squared. R squared equals 7 squared plus -5 squared. R squared equals 49 plus 25. R squared equals 74, but then we're going to take the square root of it. So now we have half of our answer, square root of 74. All we need to do is find the angle measurement. So 7 equals square root of 74 times the cosine of theta, divide both sides by the square root of 74. Find the inverse cosine of 7 over the square root of 74. We get 35.53. But remember, we are in quadrant 4. Because x is positive, y is negative. This angle cannot be that, so we have to do 360 minus that answer. We get 324.462. 324.462 degrees. So put it all together, and we have our answer.